Hello, everybody. My name is Jimmy Carroll. I'm the Vice President of Operations at Tech B2B Marketing, and welcome to this episode of the Manufacturing Matters podcast, where we aim to discuss the trends and technologies reshaping the manufacturing industry today. I have the pleasure today of being joined by Etienne Lacroix, who is the CEO and founder of Vention. Etienne, thank you so much for taking the time. Really appreciate it.
Thanks, Jimmy, for having me. Quite excited to be with you here on the podcast.
Well, thank you. Yeah, feelings likewise, obviously. So for those who don't know, can you tell us a bit about Vention and what led to you founding it?
Yeah, Vention is a story that started in 2016, where we got the idea to democratize industrial automation by giving the tool to the practitioner, right? The folks on the factory floor. And what we set ourselves to do is to create that very Apple-esque business model, taking hardware, industrial automation hardware, and software, all the software you need to design and program those robot cells and automated equipment, and bringing them into the same plug-and-play ecosystem. And the intent here was to create a very simple, very delightful user experience so more people could adopt industrial automation. The ideas actually came from myself, and younger in my career, I was a system integrator. Working out of Montreal, we were mostly serving the automotive and the aerospace industries, and I've navigated probably 40 to 50 projects during those years in what I would define as the traditional fashion, right? You go on industrial distributor website, you find parts, you open SolidWorks, you design additional custom parts. Eventually you have a machine, then you have to open Studio 5000, you start to program the PLCs, and eventually all those things come together, but it was very project-based, right? And as a result, one of the two projects, we were literally losing money as an integrators. It was pretty hard business. You have amazingly talented engineers, but a very, very hard business model because obviously you bid for winning those jobs. You take sometimes a little bit too much risk, and one out of two times, you're not making as much money as you thought. So I felt the pain of being an integrators, and around that time, 2016, you could envision a world where, hey, that whole workflow could be entirely digitalized if you have Lego parts to build machine with. So that's a little bit the founding stories and how we came up with the concept.
Yeah, so that's really interesting. There's a lot of follow-up questions I want to ask you, and I will. But before we dive into that and the Vention platform and that Lego idea, which I love a little further, I want to ask about, what are the pain points people are facing today? So manufacturers, logistics facilities, fulfillment centers, whatever, places where automation is being adopted. What are the challenges people are facing today, including the labor shortage? Right, this is an issue that's not going away. Obviously, it was sort of highlighted, and COVID exacerbated it to some extent. But it's still here today after all these years. What are the pain points that you're seeing for these companies today, and how does industrial automation technology fit into that equation?
I like to, as a continent and in America in general, we just don't automate enough, right? You look at the level of adoption of robotics in the United States versus Germany, for example, or even Korea. We are so little versus what's being done over there, and there's such of a room to automate. And I think one of the main reasons people don't automate as much is because it's so difficult and it's so pricey. If you're a high throughput manufacturers, you can buy automation on a project basis and still have very, very good ROI. And you have enough volume to absorb all the initial CapEx and all the expertise that needs to come with the integrators to put those systems together. But if you're small, medium businesses and you have a very small production volume, like sub 10,000 units a year, it's starting to be pretty hard to pay for all those technologies, the hardware, the software, the integration services, and absorb all that CapEx with small volume. And that's why people don't automate. That's why people rely on labors, which is, to your point, Jimmy, very difficult in today's world because there is labor shortages and it's not going to get any better, right? As we all know, the world is getting a little bit smaller, right? That's going to create additional pressure on finding laborers to be in our factories and operate those manufacturing floor. And so those problems are going to come even more exacerbated. And that's why automation is going to be vital. And to make automation really something that can be adopted just by, at the same pace as what, mobile phone were adopted or PC were adopted, you just need to make it so much simpler. And, as I said, we decided to take kind of the Apple approach. And bear with me for a second. I think this analogy is worthwhile for the listeners. When I was a kid or a teenager, music was free, right? You can get the entire Radiohead discography in 2 minutes if you were willing to navigate Torrent and burning CDs and all that stuff. And today everybody pays $1 per song. Back then, my parent could not consume digital music, yet today everybody can. And what Apple did was a magic piece of genius. Is they basically decided to come up with the iPod and the iTunes Store, hardware and software working together as one to create a super simplistic user experience. And it tilted an entire industry that was basically paying, or that was sorry, free, to paying along the way, enabling everybody to adopt digital music. So how about we do the same thing for industrial automation, right? Hardware and software intended to work together as one in a simplistic ecosystem, so everyone on the shop floor is able to automate. One of the things I like to say, and it's an aspirational saying, is like, it would be great if the folks that today are operating the floor becomes the folks that tomorrow are designing the floor, right? And we're not fully there yet, but I think we're definitely walking towards that vision.
So really fantastic answer. A lot for me to ask in follow up. I love that you gave an analogy. Also, one of my favorite bands, so I can appreciate that very much. I want to ask though about you mentioned small to medium sized businesses, and I think that's a question I probably don't ask enough on this podcast. But industrial automation technology, in terms of adoption, the numbers according to some of the big outfits like A3 or Interactive Analysis or some of these others, they're overall mostly positive. There's maybe a bit of flat growth this year or last year because of the numbers that went up precipitously after COVID. Numbers were always going to come down a little bit, but for the numbers to continue to grow, right? For automation to continue to grow at significant numbers, at percentages, whatever. I've always felt, and I think I've seen it echoed in the industry, that like if that's going to happen, then it needs to become more cost effective and easier for small and medium sized businesses to be able to adopt the automation, because these big companies are already using it for the most part, right? So do you agree with that? Am I right, or am I off base?
I agree to your point. Like, industrial automation for a high throughput factory has been solved. There's a great offering. The technology is mature. It works well. What hasn't been solved is how to go after small, medium businesses that have the exact same need, right? They're facing labor shortage, they're feeling cost pressure, yet there's not a good offering for them. And I think it's be simplicity, 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 so more people can do them by themselves. And there's a couple of trends that are helping with that right now. Like, we like to talk about platforming and productization, right? That was our approach. Like, if you develop this very big ecosystem of plug and play components, and you know that everything that is available is compatible, it brings the barriers of adoption a bit, lower. That was one way. Productization to me is just as interesting. Today, it's very visible that in the industry, there's productized robot cell, whether it's a palletizer, a sanding cell, a welding cell. Now they're productized kit, and they are sold usually with a performance level. And that removes all integration almost from those projects, making them more like a product and less like a project. It makes those projects less risky. And that's probably what's remaining. If you're small, medium businesses, you have a need, you find one of those productized application, the risk profile is much more interesting. But if you go to something a little bit more custom, something that has not yet been productized, that's where you're back in the traditional way of doing industrial automation, where you need a lot of integration expertise to bring those solutions. So I think we've solved the technology risk portion by platforming and productization. We're removing technology risk. What we haven't fully solved yet is process risk, right? When you automate a task, there's a lot of process knowledge and intricacies that system integrator have developed over the years of banging their head at solving given problems. And now they have all that expertise, and you need to put certain type of object into a box. They know exactly how to orient the box, right? And that knowledge has a lot of value. But it's really hard to do that today in a productized fashion. So I think that's the next frontiers around how can we reduce process risk, all that knowledge that was developed over the years around how certain manufacturing process can be, maybe perhaps embedded in a software and a platform. And I think AI, for example, is going to help quite a bit with that.
Yeah, I mean, you mentioned welding, for example. I know that it's a serious concern that the majority of skilled workers in the welding industry, and at least in the United States, will be retiring at some point soon. But the idea of putting that expertise and that, a specialized product together into one solution that can solve that problem in the future, sort of getting out ahead of that. And there's a lot of different examples like that, but I think welding is a really good one.
Mhm.
As far as the idea of making it more simple, right? You mentioned Legos earlier, and my oldest son he's 8. He's a Lego master, and we've got a lot of Legos in the house. I step on them every day, but I love the idea of again, like my brain works well with analogies of sort of building industrial automation systems, like you build with Legos. So tell me a little bit more about that, if you don't mind.
I think just like your son, Jimmy, I was a big Lego fanatic when I was a kid myself. At the time was Lego Technique, the one where you have suspensions and gears and some motors. And I did probably so many of them from, 8 to 10 years old up to probably up to my early 20s, where I played with those Lego Technique. And so the concept of modularity was quite understood. In fact, when you get later on in your Lego career, you think about what you're going to build before you open the Lego box, because all the building blocks are stamped in your brain. You know exactly, I'm going to build a four-wheel suspension car today, and you envision the entire design in your head before you open the Lego box. That concept of modularity is very, very powerful because you can do the design offline, right? And equipped with that concept and that pattern recognition, and equipped with the understanding of where CAD technology were going back in 2016, we knew that if we were to marry the two, something magical would happen. And in 2016, that's where WebGL is a little libraries that we use to do 3D in the browser. And today it's ubiquitous, but before that point, you cannot do engineering grade 3D in the browser. It was too CPU and GPU consuming. You had to do that on a desktop install software. And if you bring that experience on the desktop, you're no longer connected. The environment where you design cannot be the environment where you buy, right? That has to take place in the browser, and that was possible since 2016. That's where we envisioned, like, if we put all those Lego parts, industrial Lego parts, robot arm, conveyors, motors, sensors, structure, and we put that in a cloud-based CAD software that understand all the various parts can be connected with one another, you can do so much automation within the design and lower the barriers of adoption. Today, simple stuff like just generating a bit of material automatically as you design, computing the assembly time, managing all the fasteners for the various parts, right, that we always forget at the end of the project and then using a couple of days, managing, recommending the next best part. There's tons of parts to search and find when you're doing those machines. What if the software could recommend the next best part and learn from everything else that was designed before? When you start to work with Lego part inside a design software, you can automate a lot of tasks, and those tasks basically just make the software simpler to use. Mm-hmm. And that's very important because now you can give that software to folks that usually have a very good understanding of the manufacturing process. Perhaps they've never learned SolidWorks or CATIA or Inventors, but if you reduce the barriers of of complexity, you make it very simple, they know exactly what to do, right? And that was the experiment we were up to back in 2016, and it worked beautifully. Today there's around 2,000 Lego parts, I would say, in the Vention ecosystem, and we keep adding some more. But to make sure we don't create complexity with all those Lego parts, we're going to look at additional features like AI-based part recommendation, or sentence completion, but applied to 3D design. So when you mouse over a given mechanical context, will snap right in place the part likely to go there. A little bit like when you're in Gmail and you're writing a sentence, the next few words are appearing. We can now do that in the context of 3D design. So all of this is really geared to make it very, very simple so more people can adopt.
Yeah, again, I love the analogies. It helps me picture it as a non-engineer, right? So if somebody's building one of these, if they're speccing out a system and using your platform, right? When they get to the end and they've got a system that hypothetically will work together, what happens then? Like, for example, what do they do next? And then does Vention also do systems integration services, or is that something you shy away from?
So The story I just described is true, but there's some folks that will need support as well. So what we see is there's this groups of user of manufacturing professional. They want to do everything by themselves. They want to design by themselves. They want to deploy by themselves, do the production ramp up by themselves, and that class of users do exist. And that was one of our big questions when we started Vention. Now, as the machine get more and more complex, right, you will see a class of user that either need design help or deployment help. Usually the design help will come first, right? And there's ways to get connected to an application engineers and you get advices, and usually they will need just a couple of advice here and there, and off they go and they want to be left alone. Now, a lot of clients want to have also delivery services or deployment services. And usually this is very correlated to the complexity again of the application. And today we do offer system integration services within our ecosystem, right? So we have a team that's sole mission is to go at client, deploy solution, start the machine, train the team there, make sure that the clients get autonomous and get out, right? And we've done that all across the United States and in Europe. And if you think about, as we're building Vention in this ecosystem, this pattern is actually the same that a lot of companies have done throughout their career. If you remember when Fennec started in the late 70s, they actually had their own system integration in-house services, right? They were entering all those services. They've learned how to crack various manufacturing problems using the robot they've came up with. And eventually they've built an amazing network of integrators across the United States. Same thing was true for Boeing. I've learned that just a few weeks ago. But Boeing, when they were building their first few aircraft in the 20s, were also operating their own airlines. And eventually they pull out of the services layers and enable a network of airline to flourish. I was talking with the founders recently doing electrical vertical takeoff vehicles, and they were going the same route. Like, we're building those electrical aircraft, but we're also going to operate them as flying taxis because we want to learn all the intricacies and the business model properly before we can give that. So to some extent, we're repeating that pattern as well. So, this is a very proven way to bring a new way to go to market, new ways for people to automate, and making sure that everybody stays happy and satisfied, and obviously come back as client.
Yeah. Again, there's a lot there, and I want to ask a lot of follow-up questions, but I told you up front I'd be respectful of your time. So there's a couple of trend kind of questions I wanted to ask you about. And you mentioned a little bit earlier, and Vention uses sort of AI-based product recommendations, and I want to know a little bit more about that. But also, I wanted to get your idea of AI in general, right? AI now is a term. Just a minute ago, you said the word ubiquitous. AI is ubiquitous. It means different things to different people, though. In the mainstream, some people get afraid of AI. They don't quite understand what it might do, not realizing that, it's in their phone. You use it every day. You just don't really realize it. What does it mean to you? What does AI mean to Vention and its customers? And what are some ways that you're seeing AI add value to industrial processes today, both within the context of your customers and, the general industry?
Yeah, it's such a rich topic. AI can be used to increase the ceiling or the performance of automation solution, or AI could be used to lower the floor or improve the adoption. We're using AI to lower the floor and make it more accessible to more people. I'll talk about a couple of use cases where we're bringing AI in a second, but the general trajectory is that us and the entire industry is up to right now is to bring to bear autonomous robotics application. And by that, I mean robotics application that just need much less user input to perform the task by which they're commanded to do. For us, AI is very unique because Vention is cloud-based, and because over the years, a lot of people have made design on the Vention platform, and all those designs are made with Lego parts. That means there's a rich data set that we can learn from. And we're using that data set to predict the next best part, for example. Right. So, and those prediction algorithms today get informed, and as people are playing with new parts or testing new components, we can know if a component is better suited in a certain situation. And we're leveraging that again to make the bar of design simpler. But you stay mostly in the mechanical context. Now, when we move to the automate context, the automation side of things, Vention on the platform has a programming environment. There's one that is code free. There's one that is Python based and programming Python. And with that now comes a copilot, so you can generate prompt, right? You can say, hey, give me a function to index the conveyors by 100 millimeters every time the robot complete a cycle, right? You can just prompt that in text, and the function will be generated in Python, and you can put that in your program if you want to. You might have to edit 2, 3 things here and there, but you're there 80, 90% of the way. Now, the beautiful thing is when you program a machine in the context of its digital twin, and all the digital twin is fully labeled. There's a conveyor, there's a robot, there's an apple in the bin that needs to be put on the conveyor. Like, you can start to integrate those parts from the digital twin into your prompt and get a program that know what is referring to. So it becomes very, very powerful. And again, you lower the barriers to adoption. Now let me get to the last piece of AI, and I think that's the one that is the most exciting, but the one that's going to take the most time, which is getting to autonomous robotics application. And for that means you need to have a machine learning model behind every robot deployed on the floor. We're not there yet, right? That also means that there's vision on every robot deployed on the floor. So today, the way people do AI, or physical AI, they call it, is they're going to buy all the expensive equipment, the robot, the camera, the GPUs, and all that. They're going to start to do a task, learn from it, and eventually the machine learning model will be good enough that it can handle all the edge cases and pick the part in all various situations. And the problem with that is it's you need to front load all the capex to know if the application is going to work in the end. And if you're a small medium businesses, that just doesn't work for you because you want to make sure it's going to be risk free, right? So if you can take all the training the model and virtualize it, do that in the cloud instead of doing that on the edge, that means you can de-risk before you commit to the capex investment. So you need a virtual camera, you need a virtual grippers, a virtual digital twin where you can actually train model, test it like if you were in real life before you commit to capex investment. And with this, you can start to build those autonomous applications in a much more risk-free profile. And I think that's what's exciting about AI. I think we're going to see academic example, I like to call them. We see them already. We're going to see more next years. I think we're probably 2 to 3 years away where a sizable amount of application, by sizable I don't mean 50%, but I mean like 5-10% of application deploy leverage some sort of AI on the shop floor. And if we use that AI to make robot programming significantly easier, I don't have to program an approach point and a retract point, and you can just say, go grab the apple, and the robot can figure out by itself and avoid all collision and figure out the fastest path planning so we can do that at scale. That would be great. And that means we're closer to folks that operate the floor becoming the folks that design the floor.
Yeah. AI is like I said, like early on, like it means a lot of different things and it's applied in different ways. And I, based on my conversations, I'm not on the factory floor. I'm not actually doing these things, but I talk to a lot of people who are, and some of these things are further along than others, right? Like at first I thought generative AI might have no place at all, on the factory floor and industrial automation, and to some extent it does, and in other places it's still getting there, right? Like programming, PLC programming or robot programming might be something that's really valuable. I know big companies are doing that now. I think Beckhoff and Rockwell and some other Siemens. But then, I did a podcast a while ago with a gentleman who was a director of AI for a systems integrator, and he said, one of the things you have to worry about with generative AI, as much as I see the potential value for certain applications, is it's maybe not there yet. And he provided this example, which I thought was really interesting, and I'm going to steal it again. He said, "Hey, tell me the names of all 12 of Snow White's dwarfs, right?" And obviously, there's only 7, but the model just spit out 12 names, and the additional 5 names sounded very similar to the other 7 names. So I give ChatGPT or whatever it was credit for coming up with something similar, but obviously these AI hallucinations can't take place in an environment where such a mistake could be really bad. So it's a topic that's very interesting to me, so I always like to ask about it.
AI is a non-prescriptive technology, right? We're used to deal with very prescriptive technology. You put an input, you get an output, and the output, if you put the same input, you will always get the same output. And AI is non-deterministic or non-prescriptive. For me and you could put the same prompt in ChatGPT and we'll get different answers, right? Like, so that's why it's a non-deterministic technology. And in the world of manufacturing, where we're dealing with precision, like sub-millimeters, like precision, it can get scary, right? To your earlier point, right? What if for the last 4,000 pick you got it right, but then the next one you hit the collision that the robot did not plan, and here you go, right? Production is down for 3 days, right? So so there's a lot of, that's why I say I think next year we'll see more academic example, but there's still a couple of years for us to prove the technology and make it to a state that is ready for the manufacturing floor.
I could ask a lot of other follow-up questions on AI, but I'll save that for another time. I did want to ask, something that's curious to me is, Vention's a unique company in what you guys do. So I imagine that partnerships are very important. I mean, they're very important for everybody in the world of industrial automation today, but you've got a couple of exciting ones, a couple of new ones, right? Can you talk to me about these and maybe tell us like what this means for your current or potential end users?
Yeah. So building an ecosystem is something you need to do with people, with partners. So this is not something we ever envisioned being able to do on our own. So we've been partnering with Universal Robots and Fanuc for the longest time, and I think those relationships have been fantastic for them and fantastic for us and fantastic for our users of bringing that simplicity and that proven industrial technology together. There's two big partnerships we've announced this year, and the way usually we announce partnership is when we're ready, when there's a product, right? So we've been a little bit conservative on that side. And the first one we announced this year is ABB. And our story with ABB that joined the ecosystem and the GOFA family, their collaborative robot family, is now fully integrated in the Vention ecosystem. And ABB is a fantastic relationship for Vention and for our users, because we used to partners with them since probably 2021 in Europe, where the team at ABB were using Vention to complete their own robot cell when they were serving their client. And so they've been to some extent a client of Vention. So we were working with them on that basis. And what happened more recently is we started to work with ABB also here in the United States to automate factories in other divisions. So they're using Vention technologies so they became also a client from that point of view. But we're helping them on very strategic mission of automating their factory. So we got a little bit closer. And at the beginning of last year, 2024, we had a discussion between the this group, and now was the time, right? Like to bring the GOFA family. We had so many, 2-3 years worth of proven relationship working together, and it made time to bring the GOFA. So today we bring the GOFA in the Vention ecosystem. That means users can only design with the GOFA, they can program and simulate with physics or in code free or in Python with the GOFA. They can deploy them through the Vention stack and get all the simplicity that we provide with the analytics suites, the remote support suites, and the teleoperation suite that Vention provides. So it's great because we're again lowering the bar or lowering the ceiling, the floor for people to adopt great cobot technology. So we're feeling extremely proud and privileged to be working with ABB. The other partnership we announced this year and was also one in the making for over years was NVIDIA, that is now partnering with Vention. Vention and NVIDIA has been working together on various aspects, but mostly in the context of our plug-and-play motion controller, machine motion. Today, for the last years, we had generation 1 of machine motion, and today we're providing our client with generation 2, machine motion V2. And we've announced a little bit earlier in the fall, machine motion AI, which is our third generation. Machine motion AI for us is what I would define as one of the first products of the post-PLC era. In a world where those robots will have a machine learning models behind every single one of them, you're going to need GPUs. And right now, the best GPUs that you can get for industrial technology come from NVIDIA. So it's very natural for us to partner with them. To give you a sense, machine motion, the whole thesis behind machine motion is it's actually pretty hard to do industrial automation cabinet. Right? You need drives, you need PLCs, you need safety PLCs, you need power supply, and you need a very qualified electricians to wire everything up. And you create one of those, it takes a few weeks to serve a single machine. And we went back to that thesis of Lego-like and productization. And can we create a box that fits it all up? right? That is always good. So that's how we created Machine Motion. We contain everything that I just described, but in a productized fashion. And we wanted to remove the burden of the requiring electrician. So everything is plug and play with connector based. So Machine Motion AI pushed the frontiers a little bit more, where you can do up to 30 daisy chainable motors fully synchronized through EtherCAT, 3,000 watts of power, IO links ready, IP54 enclosure with passive cooling, over the air upgrade, because a lot of plants have, for very valid reason, have cybersecurity considerations. So you want to be able to have an autonomous machine not being connected to the plant's IT. And obviously, there's GPU in there enabling to run 2D, 3D perception models directly on the controller. So now you need one box, everything is plug and play, and you can run all the future of automation without needing any additional devices. So that was the thesis behind. Very happy to work with NVIDIA on that first products. And as you can expect, Jimmy, there will be other product coming on in 2025 as a result of that great collaboration.
Yeah, I mean, it's super exciting, both ABB and NVIDIA. I mean, anything NVIDIA just always catches my eye over the last couple of years. Just a fascinating company. And you know, one of the things you said to me offline, previously spoke, was, I don't understand why anyone would need to use a PLC once they can see what this product can do. And I said, oh, wow, all right. Well, I'm going to have to ask you about that. It's very interesting. One of the follow-up questions that I wanted to ask you about, though, was you mentioned, you know, support for 2D, 3D cameras, but so does Vention also venture into, I guess I didn't do that on purpose, Vention venture into machine vision? Does that, can users design that into the process on your platform? And what's that look like once the system's deployed?
Yeah, so very good question. So Machine Motion AI is vision ready, right? We support PoE camera, we support camera for teleoperation as well. And our pendant, the HMI that is connected to Machine Motion, also includes camera. So when you call remote support, think of this as telemedicine, but for your robot cell. We see you, we see the machine, and so on. So we're ready from an infrastructure perspective. You'll see throughout the years in 2025 us venturing into releasing some of those vision-based applications. But really the trajectory here is one of walking towards autonomous robotics, and so you'll see those announcements throughout next year.
I hate to bring up too many things that we spoke about offline, but they were really interesting, so I just want to ask about it. One thing that you said again was related to machine vision, and I geek out a little bit with machine vision because that's sort of where in a previous life I was a writer for Machine Vision magazine, right? You told me that you think that we're about 3 to 5 years away from every robot cell having a camera. So I just wanted to bring that up.
Yeah. Well, I'm still yes, but I'm still conservative, right? There's a lot of problem that can be solved with just good mechanical design. And every time you can solve a manufacturing problem with good mechanical design, I would always recommend, let's just solve it with a good frame, like a good machine frame, good positioning, good referencing, and you make the life of everybody else in the chain so much easier. But then the cost of camera is getting so cheap, right? And they will become so ubiquitous that at some point, I wouldn't be surprised if some of the engineers, I don't want to say get sloppy, but you will not need to be as skilled in geometric referencing and positioning and machine frame alignment, because you'll always be able to compensate with vision, right? You can have a crooked machine, but it doesn't matter if the parts are not presented properly. The robot will figure out what the parts are. And so, and that future to me is not that far away, right? I wish we don't get sloppy too quickly and we keep things simple with just good mechanical design. But I think there will be a point where the cost of doing those design right and the expertise needed versus the cost of just putting a camera and the software being pretty autonomous to figure it out, the trade-off will happen. And yes, perhaps that trade-off is between 3 to 5 years. Think of this as, I'll give you an example with Vention. We only have 3 motor size: small, medium, and large, right? And that trade-off basically imply that the time it will take you to right size the motor is not worth the pricing difference between each of them, right? So think about the expertise needed for electrical engineers to right size based on the load, the peak load, the power consumed, and all that. You could spend a lot of time just right sizing the motor on the machine. And we said, well, that time is actually, if you spend 3-4 hours for a system integrator, that's several $100s, and you rather use just go small, medium, large, and pick the one that is most likely you'll end up with a slightly over-designed machine, but it's just not worth the cost. And I think the same trade-off will happen with vision. The cost of doing the right mechanical design with all the expertise needed, which is let's just add a camera and leverage the machine learning model. Right? We'll be in that trade-off in maybe 3 to 5 years.
Well, in some cases, right? Like, yeah, to your point, there are a lot of applications that don't require vision, but there are certain applications, and I'm basically looking for your opinion on this, but it's sort of an opinion I've formed over the years. But adding cameras, oftentimes 3D, but 2D as well, adds a new layer of flexibility. And then, to your point, adding machine learning, AI, deep learning capabilities adds an even further level of flexibility. Yeah. Again, to your point, to be able to, let's say, inspect a part that's maybe off skew or whatever it be.
You add robustness to those applications and a fail safe, right? Like we'll deploy the machine, and if we need one more lever to make sure it works when we deploy, well, we have the cameras already there. It's part of the cost. It's pretty low cost to now add a camera. And yeah, it gives you that additional robustness, this additional fail safe to make sure that when you deploy, you'll be able to continue to improve the performance of the machine. And definitely there's a future where vision still can be tricky at times, and you still have to fight with lighting condition and all that, but we're slowly getting there.
I'm glad you mentioned fighting with lighting conditions. I've got some friends in the industry that are vehemently opposed to the idea that AI can compensate for ambient or poor lighting. So they'll appreciate that.
There's still a little piece of technology to fix for sure.
Oh, fair enough. Etienne, what else haven't we talked about today that you might want to bring up, or have we covered a good wide variety of topics?
I think it's just an exciting time to be in manufacturing. I got super passionate about manufacturing. I was in my very early 20s, and at the time I was probably the only one passionate about manufacturing and in industrial tech. All my friend wanted to go in like a tech startup and stuff like that, and I think now it's actually cool again to be in manufacturing. There's so much technology coming up, right? There's a lot of people that can contribute and be part of this. So I think for the industry as a whole is quite exciting, and we're reaching a point where the technology that is available to us is there to really make a dent in adoption, right? To really make adoption change versus the previous year. So I think we're going to have a next very exciting 10 to 15 years ahead of us here in this industry.
Yeah, no, it's something that I've been part of for 10 or 12 years now. But even in those 10 or 12 years, a term that I think I've seen you use, or your company anyway, is like, the democratization of automation. I think about where, whatever the technology may be, 3D or hyperspectral, some of these, like hyperspectral, for example, was a technology that was limited to the lab, and it was very large and expensive and sort of inaccessible. And now, or SWIR, like SWIR imaging now, it's like the cost is way driven down. It's available from a number of leading machine vision camera companies now at affordable costs, and same for 3D and so many other technologies. And your platform is a reflection of a lot of different converging technologies. And that's why I wanted to talk to you today. I reached out and I said, I want to learn more about Vention. I've been seeing you guys around at trade shows, and yeah, it's been really interesting. I really appreciate your time. For folks that want to learn more, it's vention.io, or if you have questions for Etienne, reach out to us at manufacturing-matters.com. I'd be more than happy to pass along those questions, and I hope everyone enjoyed it. And Etienne, one more time, thank you very much. I appreciate it.
Thanks, Jimmy, for having me today. It's very kind of you.
Of course, my pleasure.